something for you guys to research, yeah? Yeah, and Intel would like to hear about it. Okay, so going back to how we can do the damage, well, again, maybe some legacy CPUs, maybe the new ones are indeed signed, and it's not a feasible attack vector, but going to a legacy vector, there are CPUs and servers which never get updated, or at least their hardware is still old. I know that you can still find a lot of old hardware running at companies as a legacy, and it's working, so by touching it and having this state of mind, you can definitely use this to break their CPU, basically rewiring the way these opcodes are working and making the CPU useless. Okay, so next to the CPU we have the RAM. Everybody likes RAM address, RAM memory. It's a very favorable part of the computer, as significant direct impact on your performance, your computer performance, how much RAM you have, which frequency it's running, and etc. Now, again, the RAM memory, same as the CPU, could be overclocked to run at a higher frequency, and could be overvolted to run at a much more voltage. Both of these attacks can cause overheating, and we already discussed the problems with overheating. And of course, in an extreme case, can burn out the RAM memory in a hole. If you already have Intel in the house, I did read somewhere that in the Core i7 series, since the controller of the memory resident within the CPU, such changes affect the whole CPU. So in a way, if you overclock or overvolt the RAM controller, it basically affects the CPU.
It's kind of complicated to explain right now, but theoretically you might get that.
Okay, so again, I didn't bring it up because I couldn't not verify it, and this poor guy is not supposed to answer all Intel problems. New processors, which include the RAM memory in it, the controller in it, could be indirectly attacked using this thinking. The GPU. Well, again, we're going to do a walkthrough here. So the GPU is a must station for us. Overheating and overclocking and overvolting, it's pretty much the gamer's ABC. They do it all the time to get a better value out of their graphic processors, which is really nice. And they also do take care of a proper cooling mechanisms, and they do ensure that they know what they're doing. Doing to somebody who doesn't know what's going to happen to him could yield some funny results. And of course, you can also break your GPU cards. There is utilities. These are just things I Googled and I found, which allow you to upload new BIOS and new framers to your GPU card. And of course, the normal ones contain some good information, bug fixes, patches, whatnot. The bad ones might contain dump code, corrupted code, or anything else. Since we don't have anybody here from NVIDIA, I guess, or ATI, I don't know whether it's signed or not signed. I can say that maybe, but again, legacy does exist, so it's an entry point nevertheless. But the idea here is that it's possible, and all these applications, they are very small and they're very straightforward. Again, duplicating this code into the malware or using an already deployed DLLs to do it, it's not a big task or complicated. Do you have any questions? Okay, so we visit the CPU, we visit the RAM, we visit the computer fan. Let's go to the hard drive. A very critical part of everyday computing and something that you would like to keep intact. I will address hard drives in two matters. The solid state one, which is, is a new fashion in hard drives. Some of them comes with the MacBook and some of them comes with embedded devices. We'll begin with the traditional mechanical part. So we have excessive write and reading attacks. I will demonstrate a more in-depth of how to implement such attack. But basically, overheating the hard drive is something that happens almost every day. And hard drive, as opposed to other products, cannot have like a fan on him. So it's important to keep the temperature in check with this appliance. Of course, the wearing out. We will also see an example of how it can wear out on a hard drive. Again, will eventually lead into a defect product. And of course, the breaking. I don't know how much of you guys knew it, but an hard drive actually contains a very small microcode on it to talk with the ATA controller, or I think SATA controller as well. So you can actually attack this specific piece of code, and you can break an hard drive, just like that. And again, I guess nobody's here for some digital or Seagate to answer us whether there is an encryption on these mechanisms. I do know it is somewhat obfuscated because it's not very easy to come through and not very easy to access this piece of code. But again, we're not talking about easy, we're talking about feasible. And if this issue will have motivation and a business drive, most definitely people will find a way to get to it. The solid state hard drives can be seen as a private case of flash memory, and I will get to flash memory a bit further down the presentation, but it's very possible to break the hard drive, not in terms of not working anymore, but in terms of not be able to write to it anymore. So it's kind of defies the purpose of a hard drive. You can read and write. It will be a read-only hard drive. So if we imagine how our hard disk works, you can see that in most advanced architecture, the plate is rotating really quick, and the head basically it's a magnet which reads the information. So there is little, if any, current during this process. It's passive reading, and since the plate is reading is circling so fast, it doesn't actually have to stop it or to change anything in it. So it does get electricity in it once you try to write information that will require to electromagnetically change the plate. So what is the worst type of reading and writing that one can pose on a hard drive? Format. It's basically introduce a walk between 0 to n, where n is the number of sectors on the hard drive, and you have to write into all of these. Now, why do I call it pseudo format attack? Well, if I will do format the hard drive, and for some reason there is a power failure, or the user will notice, then he will stop the process, and maybe can retrieve the hard drive and close the computer, and I lose the game. I got detected, and nobody will activate me again. So basically, what I'm doing here is I'm reading the sector, and then immediately I'm writing it back. So I'm doing an overwrite attack, but with the same information. So at no point I actually pause notepad to the system, because the copy before the change was the actual copy, and the copy after the change was the actual copy. So I'm basically doing a mirroring from one hard drive to the second hard drive. And this very simple bash script does the job. It creates an infinite loop of read and write requests to a disk. And this is the exactly type of attack which will get the temperature on your hard drive going skyrocket. Questions? Yeah.
About virtualization, the virtualization can avoid this problem, or?
That's a very good question. I actually have an open question, which what you're just raising, I'll just say in like a short. Of course, virtualizing cloud-based systems where you're sitting with a storage with another friend, another company, and if you attacked your own storage, the effect means that you're also attacking the other person's storage.
Have you ever heard of attack commands further, something like that?
Sorry, I don't hear you.
Have you ever heard of attack commands further? You know something underlying what you're trying to say? You know, further, basically, is trying, you know, all the attack commands straight to the hard drive.
Oh, you mean that they're using the hard drive protocol?
Yeah, the
Oh, okay. No, I didn't actually went to it. The thing about this is a high-level attack, so basically doesn't matter which protocol your hard drive is connected, it will work. But I'm pretty sure that if you would like to optimize this attack, you can go down to a hard drive level and talk directly with the controller, and it will be more efficient. Questions? Okay. So the spin down attack. Okay, so you guys are using laptops, wonderful appliance, love it. One of the ideas behind hard drive for laptops is that in order to avoid damage to the hard drive, the laptop would really like you to park your hard drive head. It's a very painless, quick action that is taking place, and you benefit from it because if there will be any movement or any fall, the hard drive will remain intact, or at least will try to be intact. So what basically happens is the hard drive head is parking, and you can define after how many minutes of inactivity you can do it. And of course, when the hard drive gets a request to write information, the head must go back again, and the whole business has to get powered up. So using the same type of thinking, let's do the opposite. Let's program the hard drive to go into inactivity every 1 minute, and then we will cause some random information to be written to the hard drive. So it will like swing. And this action will actually result in the hard drive making funny sounds at the beginning and less funny sounds at the end of it, simply because it will not work. And it's a very simple, basic attack to execute, and it will work perfectly on all these hard drives that support this inactivity feature. So, yeah.
Do you have any idea of an order of magnitude of how long it would take to break an hard drive such a script?
It's a very good question. There is a lot of benchmark that is missing in this presentation from two reasons. First, my boss did not find it funny to buy hardware to break it. He said it's not a very smart business decision. The second is that depends on the vendor, the size, the quality, all these numbers can change. It could be 1 day, could be 2 weeks, could be a year. So it really depends on the grade of the equipment, the size, the manufacturer, and etc. But again, nevertheless, all of these attacks are applicable per definition. So if you will do them on your computer, which I do recommend you do them, or I will do it for you if you like, and we will see. The BIOS. Okay, so we visited many different hardware components in the computer. We talked about the CPU, the RAM memory, the fan, the GPU, and the hard drive, the BIOS. The BIOS is a very central key player in the system, and it's also a key player to automate these attacks. To begin with, breaking the BIOS actually means breaking the system. In legacy systems, it will require a technician coming and replacing the chip. In a more modern systems, there are ways to recover from it, but it's not like your usual IT comes, puts a ghost image, says goodbye, and the computer just boots up nice and clean. So breaking the BIOS is a very straightforward approach, very easy to do, and very applicable. Now, if you would like to take it a step further, we can say that many of the different elements of the attack that we introduced today, whether it's the overclocking or the overvolting, are taking place at the BIOS. So if we can arrange a rogue BIOS, a crafted one, which will be of course malicious, we can then automate both overclocking, overvolting,